All right, welcome to the first lesson of functions. This should be day 2. We're going to look at the question about what a function is versus a relation today. So before we get to the learning target, we're just going to do this warm up. So this question will be on the board when you come into class. And so I don't want you to write this down. You don't have to write it down. There's no room in really the course notes to do that. If you want to do it on a separate sheet of paper, you can, just to kind of take notes or whatever. But you don't need to write these down. We're gonna write out each one of these functions after. So the question is, the following 8 relations are relationships between two variables. So x and then y. And you probably haven't seen this before, but it's just saying that if you plug in x as one of these numbers, you can get out one of these numbers and points to where you've got, and the one on the left is always x, the one on the right is always y. Are you familiar with, we saw this yesterday, we saw this is an equation, we've got the graphs and we've got the table of values, and these are really the 4 ways to represent functions. So what the question is, what are functions and which are not? So you can think about that. Maybe you have an idea of what a function is. Maybe you took grade 11 university college math, so you know what a function is. But think about it just based on the pictures. One's a function, one's not a function, to see which kind of belong together. So it's just like a grouping exercise. You can pause it and think about it, but then I'm just going to go on and I'll reveal a little bit at a time. So the first one that we have here, with the table of values, this guy is the function. This guy's not a function. With the equation, this guy's the function. So that's if you remember, that's a line, y equals mx plus b. This guy's not a function. So remember that this is a circle. With the graphs, this guy's the function, and this guy's not the function. And with the mapping diagram, we call this a mapping diagram because it just maps x to y. It's just a visual way to show inputs and outputs. Usually the outputs are in order. That's the difference between the table of values. But this guy is the function, this guy's not. So the question is, what is a function? So learning target is, I know the definition of a function, so that's the purpose of today, is to find out what a function is, and you can differentiate between a function and a relation. This isn't the best way of saying it. We should just say a non-function, because something can be a relationship and be a function at the same time, but if it's not a function, we just call it a relation. So what is a function? Going back to these, we can kind of come up with an idea here. And so we notice that actually a function is a relationship between two variables. So it is a relation such that for every value of the independent variable, there's exactly one value of the dependent variable. Or the easier way of saying that is, for every x value, there is one y value. For every input, there is one output. We'll say it like that as well. So you notice over here, if we have an input, we have one output. Over here, if we plug in -1, we actually have 2 outputs. And that's a problem because if the function is automated, and say it's a computer and you tell it to plug in -1, you have to decide which road to go down. You can give out 2 values, but if you're actually going to use that value to actually subtract by something else, or add something else, or multiply to something else, and you don't know which one it is, that becomes a problem. Over here you can see that 0 yields 3 and 0 yields 4 down here. This is a circle, so it's actually easier seen on the graph. If you plug in a value like 4, you don't know if the output's 2 or -2, and that's what makes it not a function. Okay, so think about that for a second. We're going to look at some examples of functions and non-functions. There's the 4 ways to do it. We can mapping diagram, table of values, graph, equation. We'll work through those 4 ways. The first one, this is where I'd write down those examples. We're just going to show those examples the same way we had the mapping diagram, where you don't have to write so many, but it's just that each one goes to only 1. It's okay that -1 and 1 both point to 5. That's not the problem. The problem with a non-function is that -1 would point to 3 and 4, and 1 would point to 1 and 2, and that's the problem. But you can get, like, the fact that 4 points to 3 and 2 points to 3, that's okay. It's just what makes it not a function is these guys here. So every one has to point to only one value. You really just need to know what to do when you plug in an input. Table of values, you've got just like a number coming up twice in the x column. You can pause at any time if I go too fast. The graph, as long as like each x value that you sub in, you only get one y value. It doesn't really matter what the picture looks like. We'll see this function later on in the course. This guy is actually a parabola on its side. We'll see this function. This is a relation. It's the inverse of a parabola because it's on its side. So if you look like if you turn your head sideways, you could see the quadratic. But because when you plug in an x value, you get more than one y value, it's not a function. Vertical line test really helps with a graph. That's why we put it on this slide. If you plug in a vertical line anywhere on the function, I want to say anywhere and everywhere, not just one point, you should only pass through at most one point. You might pass through nothing, and that's okay. It's just and we'll talk about that later, but it can only pass through one point. So watch the vertical line kind of come in, and as it kind of goes, it can only pass through one point. And that's the vertical line test. You notice that the first one passes, and the second one fails right there. Okay. In an equation, we've got like one x value giving one y value. You can see that in a line. Here, as we saw yesterday, if we sub in an x value, so we put x squared on the other side by subtracting x squared by both sides. If we sub in an x value, because when we take the square root, we have to think about that plus or minus. That's going to give you two outputs for each input. So if you plug in an x value, an input, you're going to actually get two y values because of the plus and minus. So why are functions important? Functions are used in technology to allow it to operate. I kind of alluded to that earlier. If you plug in an input, the computer has to give an output. When a command is given, then an action has to be taken, and there has to be a result. Sometimes that result we don't actually see. It's used for something else. And so that's why it's important, because we can't just give two results and decide which one we want. The computer really has to decide which one to take. And so that's why functions are very helpful, because it only has one. It doesn't have any decisions to make, and a computer really can't do that unless it's been programmed. I just want to give you an example of a demo in Alice, and so I'll post this YouTube video separately so it doesn't make it long. You can watch it if you like. It's really to talk about kind of computer science. It's a really interesting idea, but it shows how like functions are used to make things move, to talk, to make a character talk. It's kind of a cute demonstration because it's got the Garfield characters. So you can take a look at that. It's just me talking through a simple little program I made with this program called Alice that's offered free through Carnegie Mellon as like a mission to help kids learn programming. And so if you want to check that out, you can just click it in the PowerPoint. Just click that link, and I'll post the PowerPoint for that one as well. Okay. And so here's your practice. It's really just like going through examples of which are functions and which aren't, and asking some questions. Okay.